are staying in the call or you just having me and going off. Okay. So can you all are you all aware of what is probability?
Yes, ma'am.
Yeah, can anyone please?
Probability is basically a calculation of favorable outcome out of total outcomes. So if there is a uh, tossing of a coin, what is the probability of getting a head? That would be like half of the.
Okay, it is a good answer. So, basically, what a probability is that it is an uncertainty of occurring particular event. Okay, so for example, if I'm trying to toss a coin, what is the probability of getting coins? Like we can get a head or a tail. Okay, so that is the probability of occurrence. So we can take one example and try to evaluate. So now I'm taking this example. So where we have the probability, consider this is going to be an event A, okay? So where I'm going to toss my coin. So the probability of occurrence of tossing a coin is you have a head and a tail. What if I'm asking you the probability of getting a head? Okay. So in this, the probability of getting a head is 1, no? So the total probability will be like event divided by the total sample. Okay. So the event is the probability of getting hit. So how much probability we have? We have only one. Okay. So the total sample is 2. So it is 1 by 2. So every time the probability always would be between 0 and 1. Okay. So it cannot be above 1 and it cannot be below 0. Okay. So consider now I'm going to toss 2 coins. Okay, so if I'm going to toss 2 coins, it will be the probability will be like head. So from one coin, it will be like head. In another coin, again head. So in one coin, it will be like tail. In another coin, also tail. So one coin will consist of tail, another coin will consist of head. So head and tail. So these will be the probability. So now, what if I'm going to ask the probability of getting head? Probability of getting head.
3/4.
Yeah, it is 3 by 4. Okay, so firstly you have to see where all the head is there. So here the head is there, here the head is there, and here also head is there. So it is totally 3. So what if I'm going to ask the probability of not getting tail?
1/4.
Yeah. So probability of getting only tail.
1/4.
Yeah. I think all understood now. So that is how you can find the likelihood of occurrence. And you have a number of examples. Like you can also take the example of mm, a deck of cards. Okay. In deck of cards, how much probability you have? You have probabilities of 52 cards, no? 52 cards probability you have. So what if I hope you know what are all the cards in deck of cards. We have spade, diamond, flower, and heart, and no. So in this, what I'm going to ask if you have the probability of getting only red card. So red card means this heart will have 13 red cards. Okay. And this diamond will have another 13 red cards. So which is added together divided by the total number of cards. So which is 26 by 52. Okay. So this is how the concept is evaluated, and the how the probability works. So, and this probability consists of two separations or types. One is classical probability, and next one is subjective probability. So, in classical probability, you have um, classical probability means you will have equally subjected events. For example, tossing a coin, throwing a die, picking a card. So, if the actual example or the personal beliefs, if those kinds are to be there, that is your classical probability. And subjective probability means the occurrence is not confirmed. For example, the election vote. In election, if somebody is going to win or not, so that is not for sure, no. So if the event is not going to occur and it is not for sure, it is only based on your prejudgments, intuitions, and personal judgments, means that is based on your subjective probability. Classical probability means something is going to occur and you know what is the outcome. Okay, so if you are going to be sure of your outcomes, so that is your classical probability. If you are not going to be sure of your outcomes, so that is your subjective probability. Okay, so then moving on to concept of set. You know what is set? Okay, so I'll tell. So firstly, in set, so how I am going to represent set is that this is how I can represent set within the flower brackets. Okay, so inside this brackets, we can have any samples. Like you can have a video sample, audio sample, or you can have an array. You can have the sample like any documents, anything you can have inside the set. So this is how the set is done. The set is of few types. One is empty set, universal set, and complement set. So so consider I am going to take the samples as 1, 2, 3, 4, and 5. Okay. So this is how the elements I can have inside the set. So if the set is going to be an empty set, I don't have any elements. So this is what an empty set is. Universal set means, so this is my setting, okay, the whole sample space. If I'm going to concentrate only on the A component, so what I had in that brackets, no, which is A equal to 1, 2, and 3. If I'm going to concentrate only on that A thing, that is will be my A content. If I'm going to concentrate on the things which are outside of A, which is my A complement. Okay. So that is my universal set means the overall things which I'm going to consider. For example, consider the sample. The sample is going to be 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now I'm going to take only the A as this one. If I'm going to ask you what is A complement, uh, the other components which I have not represented in this A, that would be added. Okay, so which are not in the same is 6, 7, 8. So the A complement will be 6, 7, and 8. Okay, so this is how it is represented. So if I'm going to ask the whole sample space, you should combine both of these elements and you have to represent. Okay. So although this looks like a very basic concept, this all these would be used when you are doing the ML coding and all. Okay, so don't think these concepts you know already and this is very a basic concept and all. So all these will be used in the later sections. Okay, so then you have this intersection and union. So let's see what is intersection and union. Okay, so now let me take two samples. One is A sample, which is consisted
Can we
of.
go with some examples like can you open and do some examples?
Example means in which topic you are asking?
Uh, everything, whatever we are discussing one by one.
I'll give you questions. Later you can work on. I have questions as well for you to work on. So, or else if you want me to directly assist you with questions also, I can do. I thought no need to waste on all these things. Okay.
No, ma'am, no, I'm not asking like that. Can you open the script and type with some example?
I'm typing only. You cannot, can't you see the screen? Actually, I'm showing you one document file. You are not able to see?
Yes, ma'am. But it's just explanation, right? What will be the output, direct output
Oh, you want
by
to see
running?
the view of the
Uh,
screen, how that would be. Okay, fine. I'll show
yeah,
1 minute.
yeah.
I have to search for the file. 1 minute. I missed that PDF somewhere. I have to search for it. Today I'll explain you the concept. Tomorrow we can work on actual thing, okay? I have to search for it. No need to waste time now, okay?
Okay, ma'am. Like in interactive notebook, you're telling, right?
No, it's not like an interactive notebook. It's like a Word document which where I have already worked on the concepts and have how the output will look like and all. So now I'm explaining, so all that I have like a theory concept. I'll show you tomorrow. Okay, I have missed that PDF somewhere I have kept. I don't know where I have stored it.
Okay.
Hope you are convinced.
Bit.
Hello.
Yes, ma'am.
Tomorrow I'll show you. So we are
Yeah.
there going to be here for another 30 to 35 days, no? No need to worry.
Okay.
I'll explain you today. Tomorrow we can work on the actual concepts. Okay, so consider I'm going to take the sample for two things. One is for A. So another one is for B. So if I'm not going to ask you what is A union B means, so every unique element should be combined. Okay, so unique elements means it should not repeating both and you have to combine both of these. So like this you can combine just 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma and 45 you have and you have 7 8 9 and 10. Okay, so this is how A union B looks like. You have to combine both of these samples and together you have to get the samples of A union B. Okay, so if I'm going to ask you what is A intersection B means, so it is repeated elements from both A and B. So which is repeated elements from both A and B means A comma 1 comma 2 comma 3 comma 4, and you don't have any other repeated elements. You have 6. Okay, so these are all the elements of A intersection B. So in A union B, you have to take all unique elements and print together. And in A intersection B, you should take the repeat elements and take it out and you have to print it. Okay, so this is what for A union B and A intersection B.
Actually, 4 is not repeating. So,
Okay, 4 is not repeating, you can take it out, no problem. It's just an example, no? So if it is not repeating, you can take it out, no problem. You understood the concept, no?
yes, ma'am.
So we completed this empty set, universal set and complement, and we saw what this Venn. And actually, this is about a Venn diagram. So what is Venn diagram means? We now saw what is A, what is B, and how the sample will be stored inside that A, B, no? So that is like a concept oriented thing. So those concepts can put inside a Venn diagram. So this is what a Venn diagram looks like. So the Venn diagram will be consisting of a square. Inside square, we can have that both the samples together. Okay, so if we are going to have 3 samples, we can have together. If we have 4 samples like A, B, C, D, you can have together. Okay, so now have only 2 samples like this, which is A and B. So all the elements of, so now I taken the samples of A as 1, 2, 3, 4, 5, 6, no? So that 1, 2, 3, 4, 5, 6 I will be having inside this A. And 1, 2, 3 in the components of B I will be having inside this B. Okay. So the common elements of A and B I'll be having in between this space. Can you see the space? So that this is about my intersection. So all the elements will be placed together outside. So 1 minute, someone is texting me. Okay, so all the other elements I will be having inside this intersection, which are common to both the A and B. Okay, so this is a representation Venn diagram for this set. A union B means the whole of this. This yellow part is A union B. A intersection means only this curvy part. This oval part is A intersection B. So if we are going to have a concept called as mutually exclusive set. Okay, so if your components of element in A and components of element in B both nothing have in common means you can have separately, like this won't join together. So this is also called as a disjoint set. For example, consider now in A we are going to have numbers. In B we are going to have any kind of alphabets, like this. So this cannot be joined together. Okay, so if you want also you can join, but this is not you cannot join it. Okay, so if you're going to have like this kind of example in real time, you can say A is equal to height of a person. Okay, height of a person is, you will be having 160, 158, 150, like that, no? but the weight of the person don't have dependency of the height of the person. Someone will be in the height of 160 and have the weight of 50 or 55. Okay, someone will have the height of 160, the same 160, and will have the weight as some 70 kgs or 80 kgs. So if your component of A and B doesn't have any dependency of both, so that can be put inside this mutually exclusive or disjoint set. Okay. So we saw a few examples, no, for probability. One is tossing of coins. Another one is tossing of die. So die means that if you are going to play snake and ladder or Ludo game, you have the die, no, which consists of 6 outcomes. Okay. So these outcomes and all we can discuss tomorrow, where I'm going to show you concepts and how we are going to evaluate it. We can look into it briefly. Okay. In probability, you should be aware of few wordings. One is like sample space. Okay. So sample space is nothing but the total thing what I'm going to have. So the total thing what I had here is this component, no? So these two are considered to be a sample space. So sample A, sample B. So be aware of the wordings what is used in probability. So and also you can call it as an event set. Okay, so if you're going to represent all the event together, that is called as your universal set. Okay, so if I'm going to ask you one event, consider the probability of getting tail, consider the probability of getting head, so consider the probability of getting a king. So if specifically I'm going to concentrate on one event, so that is called as an event. Okay, so the group summed up, and if we are going to calculate the event as well as your sample space to be calculated together, that is called as your probability of an event. Okay. So if some topic or in between, if you are not understanding, you can text me in the WhatsApp or then and there. Okay. So don't text me after the call. So then and there, if you are not willing to unmute yourself and ask here, you can text me and ask. Okay, some people will feel what we cannot ask questions in the online chat. So you can don't face problem like that, or else in Teams itself, to have any kind of private chat here. Don't be idle in the class if you are not understanding. You can also ask here in the message and ask. Okay, so please don't be quiet.
Okay.
So far, any doubts for anyone?
No, ma'am.
Okay, so and I told already no, so this probability will be always ranging between your 0 and 1. Okay, so it will be always like greater than 0 and less than 1. Okay, so if you are having the probability of A, like I'm asking here, um, let's take this example itself. Let's take this example. So now I'm going to ask you, what is the probability of getting 1? Okay, so now you people are saying the probability of getting 1 is 1 divided by the total sample space here is 5. So this is about the probability of getting 1 in this sample A. Okay, so now I'm going to ask you, what is the probability of not getting A, not getting 1? Okay, so at that time, you no need to calculate, go here and 1, 2, 3, 4, 5, and no need to calculate anything for not getting the possible event. Okay, so for that, you have a formula which is 1 minus probability of A. So now if I'm going to ask you what is the probability of not getting 1 means, you can directly answer me. So which is 1 minus 1 divided by 5. 1 minus 1 divided by 5 means 1 minus 1 by 5 is some answer, which is what is 1 divided by 5? 1 divided by 5 is 0.2. So now the output will be like 0.8. So if you are aware of the positive events, and what if now I'm going to ask you probability of getting 2? Can anyone?
One by 3.
How 1 by 3?
There are total 6 elements. 2 are 2.
Oh, you
So
already uh, cut down that. Okay, fine. It is like 2 by 7. 1, 2, 3, 4, 5, 6. Okay, it is 2 by 6. So that 2 by 6 you will be evaluating and you will be getting 1 by 3. Okay, so now I am asking you what is the probability of not getting 2 means you can just do 1 minus 1 by 3. That will be your output for not getting 2. Okay, so now hope you understood this formula. Okay, so next is about intersection. So this intersection can also be calculated with one formula, which is probability of A intersection B is equal to number of samples of A intersection B divided by total number of sample space. Okay. So this intersection we already performed, no? So where it is here. So we calculated the intersection, no? So what if I'm going to ask you what is a probability means at the time you have to denote between 0 and 1, correct? So now I can do the total number of things here in intersection, which is 1, 2, 3, and 4. 4 divided by total sample space. So how many sample space I'm having here? Which is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so just 4 by 10. The total number of samples and the number of samples in A intersection B. So by this formula, you can calculate the probability of both A and B. So mutually exclusive event means you won't have anything in intersection, like this intersection is going to be 0 because you cannot join both, no, if it is going to be both mutually exclusive set. At that time, you can have it as a 0 like this. Okay, so the time is 8:48. We can conclude here itself because she told like it has to be concluded between 8:45 now. So tomorrow at sharp we can start the class by 7:45 and end by 8:45. Fine for all. I'll also talk with the team now. Others.
Okay.
Okay, ma'am.
Okay, so from tomorrow we can start. Okay, people join by 7:55, 7:45 at sharp. Okay, so maximum between 7:50. Don't exceed. Okay, thank you. So if any concerns you have in the class, you can text me in the WhatsApp or in the group.
Can
Mostly
you
have
share
the
the
chat in
notes?
the group. Yeah. Yes. Sorry.
Yeah. Can you share the notes of today?
I didn't complete it today now.
Okay.
You have
Okay.
some more things to be covered. So if one like consider this is going to be the PPT of the class today. If I'm completing it today, I'll share you. After completion
Okay.
of every PPT, so every PDF, I'll share you. Okay. Because there
Okay.
would be confusion. So that's why. If I'll also edit something if there is needed or not needed, I'll just remove it and show you. If I am
Got it.
going to add something, so there will be not a much clarity will be there if I'm going to share in before. Hope you can see my screen. So yesterday we were seeing the concepts of probability. So in this module itself, we'll see some of the probability problems in the later stage. Now I'll start with central tendency. So just we will go by our syllabus itself, so that you will be having a better clarity. Okay. So yesterday I was starting in between the syllabus of probability, so that won't work. So today I'll start with the work which is from the syllabus itself. Okay. So if I'm saying right, okay, please give me a thumbs up so that I can understand whether you are adhering to the class or not. Keep it interactive, okay? Yeah. Uh, okay, so let's start with statistics and data science fundamentals. So firstly, for the statistics and data science fundamentals, it is very crucial to learn. Why? Because you will be needing it in processing your data, and for some machine learning tasks, everything will be needed. So for that, you should know about certain statistics and data science oriented fundamentals. So we shall concentrate on that for few classes for maybe 1 or 2 weeks. Okay, so probably by 1 or 1.5 weeks, I'll be trying to complete it. Okay. So firstly, the topic is about central tendency. In central tendency, this mean is very important. Okay. So why mean is important is that imagine you have a data set that can be your the salaries of employees, temperature of every days that is recorded over a month. All that are going to be a kind of data set what you're going to have. Another kind of example is consider you are going to watch a Netflix film. Okay, so what are the data sets next Netflix will be collecting from you? The data sets which they collect from you are the movies that you watch, and the time when you watch, the PC where you're working, and the past history of your data. All the things Netflix will be collecting from you, those are called as your data set. Okay. Consider you don't have a single value or a value is missing from your data set. So if you are going to face those kind of problem, and you are not able to substitute those value with some other value, means there would be a problem now. So for that thing, we need the central tendency. And one of the other example is also what I've specified here is consider if someone is asking you what's a typical temperature in your city. You wouldn't list the whole single day's temperature, no? So temperature of particular day will be like 39 in the morning and like 40 in the evening. It will be always changing from one temperature to another temperature. But if someone is asking you what is the temperature for today, you will be representing with only one value, no? That would be a group of value together. You will be specifying with one value. So those values can be occurred by using the measurements called with the central tendency. So this central tendency can be measured with three things. One is mean, median, and mode. So today we'll focus entirely on mean, and also if time permits, we can focus on median and mode. Okay, so first of all, what mean is that it is often called as an average. Okay, so average means consider I'm going to take the values as 1, 2, 3, 4, and 5. Okay, so I'll be taking addition of all these components divided by the total number of values. So for example, the mean formula would be number of values divided by number of sum of all the values divided by number of values. So you'll be representing with this formula, which is mu is equal to summation of x divided by n. Okay, so this mu represents the population mean, and the sigma represents the sum of, and this x represents the individual value. N is your total number of values. So let's take one simple data set and work on this problem. Is Swarna present in the class? Any
No,
PM
ma'am.
Ernest?
I think
She
so.
only asked today she need class at 7:45. So we just changed the time and now she's not present. Guys, try to be present for all the days, okay? Don't take leave. So we'll just confirm whether she will be there for our next classes, or else we can change the time to 8 itself if others have want the same thing. Okay, so now I'm taking a simple data set which consists of these values, which is 85, 90, 78, and 92. How we have to calculate the mean is that we have this formula, which is sum of values divided by number of values. So firstly, I'm taking sum of all the digits, which is 85 plus 90 plus 78 plus 92 plus 85. Altogether, I have this 430 together. Okay. And number of values, what I'm having in the data set is that 1, 2, 3, 4, and 5. So 5 number of students. So now I have to divide both, and I'm acquiring with the mean score. Okay, so secondly, I'm taking one more example. So here, let's take one real world application. Okay, so where a company tracks a daily sales week. Uh, on Monday, it is tracking this value. Tuesday, this value. Wednesday, this value. Thursday, and so on. Okay. So totally, I'm trying to take sum of all the values and number of days by dividing together. I'm just getting this value as this one. Okay. This mean itself can be divided to two types. One is arithmetic mean and weighted mean. Okay. So if you have any doubts, you can stop me in between. Okay. So this mean itself can be calculated or separated to two types.
Ma'am, how do you define central tendency?
Central tendency is nothing but it is a kind of single value or a representing a small value in your data set. To group your data set value together, you have to specify it with a single value. Okay, so that is called as a central tendency. For example, I'm going to ask you what is temperature of today. You are specifying with single value, no? I'm going
Yes.
to ask you what is the IMDb rating of certain movie. You are representing some value, no? So that
Mm.
value is acquired with group of values. For example, how IMDb is calculated, like n number of peoples are giving reviews. So altogether
Mm.
they are grouping together and the single value is acquired, no? So that is your central tendency.
Okay.
Okay. So in central tendency, you have three types. So now we are with mean. So in that mean, again, it is separated to two types. One is arithmetic mean, another one is weighted mean. So arithmetic mean is just what we saw now. Okay. So we'll be having all the data points together and adding up and dividing with one value. So again, we'll be getting the answer as some value. So that is the common type we will be using. Another type is this weighted mean. So weighted mean is nothing but it has some different importance. For example, if you are going to have consider I'm going to give a grade for your course. Any doubts?
No, ma'am.
Uh, So consider I'm going to give grade for your course, what you're attending now. So how I'm giving you the course is that I'll be providing you weights for each days, like today what you did, tomorrow what you're going to do, and whether you are attending to the classes or not, and whether you are attending test in a good possible way, whether you are attentive to the class. So every aspects I'll be giving some weightage to your performance. Okay. So in this for assignments I'm giving one weightage. For midterm I'm giving one weightage. For final exam I'm giving one weightage. So for every columns it will have some value, no? So that value will be multiplied with that individual value. Together we will be getting it and dividing it by a number. Okay. So in this example, let's take these weights for assignment as 40%, 30%, and 30%. The formula is value into weight divided by weights. Okay, so what is value for this? 85 is the value for this assignment into the weightage is 40%. Since this is a percentage, we have to convert to decimal point, which is 0.40. 85 into 0.40 plus 78 into 0.30 and so on. If you are going to have n number of aspects, you can just join here, okay? Dividing it by the weights, the total weights. So what is the weights here? Just 0.40, 0.30 and 0.30. I'm adding it and together you have the value as 85. Okay, so if you are going to consider weights, it's called as weighted mean. If you're not going to consider weights, it's called as an arithmetic mean. So in data set, when to use mean is that if you're going to consider any kind of average value, for example, I told that this IMDb rating, no? So how IMDb rating is called, got, that we'll be considering the average of review values of all the consumers and we will be giving the value, no? So for that, we will be considering the average value. In that purpose, you can use this mean. And if your data is going to be symmetrical without extreme values, for example, symmetrical means in this consider, we have values as 85, 78, 92. So there is a toggle, no? Consider you're going to have the values as 30. Okay, in that time, we cannot consider the average value. Okay? There should not be any outlier in your values. For example, let's take this example. 1, 2, 3, 4. So it is in the differentiation of 1, 1 and in between. Okay, consider I'm going to take 60. So there is an outlier, no? So these data set is not symmetrical. So at that time, you cannot use this mean. So then where you can use is for interval or ratio data. So ratio data means if you are going to have interval means we now saw one example, no, 1, 2, 3, 4. So which has interval of 1, 1, 1. So in that kind of data, we can use this mean. So then advantages of mean is that you use all data points in your calculation. So that is one of the advantage. And it is easy to understand and calculate. You have unique value or each data set, algebraically defined, and it is also mathematically stable. So that is all your advantages of mean. Disadvantages of mean, as I told already, if there is going to be any outlier means the values which is differentiate from other values. If you are going to have some kind of values like that, this mean is not eligible to use. So it cannot be used with your categorical type of data. For example, if you are going to have in your data set, I'm going to have data set as today raining or not. If the data set will be like yes or no, no. So in that categorical type of data, this mean is not used. Okay. So that is one of the disadvantages. So if there is going to be an outlier, I'm going to calculate mean. It cannot be an actual value from data set. Okay. So that is also one of the issue. So here I have given some of the examples. If you want, you can just go through this. Okay, here I have taken one data set and worked on how the mean would be. Here I have taken one. So you can just see this and learn it. So now let's get into mode and median. Okay. So let's understand what median is. This median is like a kind of middle value what you are going to have. Okay. So for example, let's take this data set, which is 1, 2, 3, 4, 5. So if you're going to find the mean, you should first arrange them to ascending or descending order. Then you can come up with the output for the median. Okay, so how we have to find the median is that the middle value is called as your median. Okay, so first we have to arrange this to descending or ascending order based upon your need, and the middle value represent, and you have to divide it to two halves. And after dividing the two halves, the middle value is called as your median. Okay, hope you understood. So then we have to go to median is that. Think about you have an income data. Okay. If you have 10 people in a room and 9 earning this $50 and 1 million people earning uh, this $1 billion. Okay. So this mean income would be over 100 million. Okay. So that is not possible to calculate by using mean. So what we do is that the median would be this $50,000. So which is more representative. So that when compared to using mean. So in that case, we can just go with this median. Okay. So as I told already, you have to arrange your data set in your ascending order or descending order. So then you have to separate into two halves. So after separating into two halves, you have to calculate the middle position. So consider here I had the values as 1, 2. Here you have odd number of values. So it is easy to get the middle value. Consider if your value is going to be an even number. For example, the number of components here is even number. Okay, so at that time it is not easy to calculate. So what you have to do means here you have two values no in between. Like after separating into two halves, in middle you have two values. So that value can be averaged together and you have to calculate mean of this value and get the median is average of two middle values in between. Okay. So if it is odd, you can directly take the median, and if it is even, you just take average of both and get the value. And you can also directly apply it with one formula, which is n plus 1 divided by 2. So n is nothing but total number of components plus 1 by 2 is nothing but if you have data set 1, 2, 3, 4, and 5, 5 plus 1 divided by 2, after arranging all the elements, the third position element is 56. The output is 56. Okay. By this formula also, you can calculate. If it is going to be a data set which consists of 20 or 30 or 100, or consider you're going to have 1 lakh data set. At that time, you cannot go calculate, find the middle element. That is impossible, no? So in that case, you can just apply this formula and use it. So these are other examples where I have taken this data set and evaluated. I have arranged the elements. I have found we have 6 values. So the question would be 3 and 4 in the middle. So I'm taking both these values and taking average. So if it is going to be 2 elements, you can just take 2 elements and dividing it by 2. That would be finding the middle value. The average would be 39.5. So after that, I can find the median value. So in real world example, I have taken housing prices. So mostly you'll have consider you are working in a bank. So you have the data set as salaries of the person, how much the person has got loan from other. So those are all will be your data set. And consider you are working in a construction. Okay, so there your data set will be look like housing prices. So consider you're working in Netflix. So your data set will be the movies customers are watching. So consider you're working in a social media website. So there your data set will be feed of the person, reels posted by the person. So this is what a data set. You should not the person you don't know what data science is, what a particular keyword called data set is means. You know what is the data set? Can anyone answer so that I can proceed further? What is data? What is data set?
Dataset is entire sample space, kind of all the elements in the.
Let me take one example and the person who's very new to this AI and data science, I've seen people who ask me question of what is data set, and also that I want to make it. See, just I have open Kaggle. So here you can have your entire data sets. Okay, so this is the data set of diabetes. So where we have these values, pregnancies, glucose, blood pressure, skin thickness. So these are all some of the columns we have. Okay, so these are all called as a data set. So these values will be there for n number of people. I think the data set of diabetes would be like 70,000 rows or something. You can see the all these data. Okay, so data can be of any format. In CSV format, we can have video format, text format, image format, any format of data set we can have. So probably we will be dealing all data set converting for consider if you're going to work with image, it will be we will be converting it to a value only again. Okay, so you cannot directly handle image. So everything will be converted to one value by using all your algorithms and all. So we'll see later. So first of all, I want to confirm you what data set is. These are all called as video. Okay. Oh. So you can have a question. It's like when to use this mean and all. So in when to use median is that in mean you had a problem when you have outliers, you cannot use mean. But if you have outliers, you can use this median. Okay. So, and you can use median and skewed distributions. So we'll see this later in the classes. So what the skewness and distribution are. So and we can use an ordinal data. So ordinal is nothing but this low, median, high kind of values. So in that purpose, you can use this median. So when you want the middle value, you can use this median. So what are the advantages of median is that it is not affected by extreme values and can be calculated for ordinal data, and it is also easy to understand conceptually. So disadvantages of median is that you don't use all data points, difficult to work with mathematically, so requires data to be spotted first. So when you are preparing for any kind of interview, you can just go through this notes. My notes are in such a way that I can teach as well as you can prepare for your interview. Okay.
Ma'am, one question.
Yeah.
So if we have any categorical data which cannot be sorted in ascending or descending, so then we can't use mean on that data, right? Median on that data.
Yeah. We cannot use it. So for categorical data, you have this mode. I'm coming. I'll tell you. So now let's understand what mode is. So the mode is the value that appears most frequently in your data set. For example, if now you told if you have category data, we cannot sort it now. So mean is mode is nothing but consider these are all the categorical data what we have, which is red, blue, green, blue, red, blue, yellow. So in this sense, we can just group all together and see which is most repeated, and you can take that value as your output. Okay. So this here, the most repeated value is blue. So I'm just taking it and using it. And one more thing, conceptually, you know all these things. And in future, we can see how to code all these things. Okay, we can just code it by using NumPy or TensorFlow for this main mediate mode and all. I'll teach you how to do. And people, are you aware of coding Python?
Yes, ma'am.
Everyone?
Yes, ma'am.
Not much, just basics.
Uh, okay, so basics in the sense you know NumPy pandas and all, no?
Yeah, I know that there are libraries like that. Have used it little bit, not like basic things.
Okay, so basically people are from which background? Can you type in the chat? So can I have better clarity of the people and start? Everyone should reply. We are only few people here now. Hope you can reply to the message. Yes. If you are working, say I'm working in this platform. If you are not working as a fresher, just type fresher. And from which background you are, I just want to know. This is a kind of heterogeneous class, no? So it is also easy for me to evaluate you all. So that my class would be in such a way. Computer science. Okay. Others. Radhi, Tina, Keshika. Others. People, please reply. Okay, you just reply in triple-C later. And surely all should reply. Sudarsanam, Manoj, V.
Ma'am, I'm unable to chat. I mean, to send a message in chat. So my background is data analyst and data science, which I took, ma'am.
Okay, okay. And you should join here with your ID number, what is provided with Besant Technologies. Okay. Don't join with your name.
Okay.
Okay. So if you are not comfortable with Python, so you have like 1 week in between. Just try to cope up with Python. Okay. At least you should know to code, like what is input, output, and how the statement is called, and few concepts in NumPy and Pandas. You can learn from websites like YouTube, Coursera, and it's also about type. No need for Coursera. You can have this YouTube and learn. You would have better clarity. Before starting coding, please be sure with all these concepts and come back. Okay, Tina. Fine. So that is about this mode. So the most repeated value will be taken care, and we can take the mode value. So again, this mode is of 4 types. One is unimodal, bimodal, and multimodal. So if only one value is going to acquire frequently, so that is called as a unimodal. If two values are going to acquire the frequency of two values are same, that is called as a bimodal. In multimodal, you would have more than two values that you can see repeatedly. Okay, so that those frequency of values should be high, so that is called as a multimodal. No mode means all values appear with equal frequencies. Okay, so that is called as your no mode. So let's take one example of unimodal. So for example, test score, I'm taking this test score. I'm just seeing which value is most repeated. So this is 85 is repeated, so the mode value is repeated. So this is 85 is repeated, so the mode value is 85. And in by model, I'm taking this value 7, 8, 9, 10, 7, 8, 9, these values. And this mode is going to be 8 and 9, because 8 and 9 is repeated together, which has frequency of 3 times. So I'm taking this 8 and 9. No mode means no value is repeated. So at that time, you cannot take this mode value. Then you have to go with other things, which is median or else mean. Okay. Then you have this categorical data like this. So in that time also, you can take this mode value, which is most repeated. And you can use this mode. As Ibn, you asked one question, no? Like in categorical type of data, what you will do. So this is the answer for you. In categorical type of data, you can use this mode and proceed. Okay. Some of the real world applications where we use mode are in retail. We can use, why in retail means most commonly purchased product size, most commonly purchased product item, product location. So all those things you can use this mode. In healthcare, you can use where you can diagnose most common diagnostic. For example, in November or in the rainy season, it is said that the flu is more, no? So how we are saying it, the most common acquired data for the past 10 years or 15 years, we'll take that and we'll be coming to a conclusion. In rainy season, what are the diseases are possible? So in that way, we can use this mode. In education, we can use where the most common grade in the class. So at that time, we can use. In manufacturing, you can use where most frequent defect item. So here are all the possibilities where you can use this mode. So when to use mode is for categorical and nominal data you can use. This I am specifying it as a categorical nominal data. If you're not understanding what is categorical, what is nominal and all, well, moving to ML concept, we can concentrate more on types of data and how the machine learning concepts are. If you're not understanding it now, just leave, okay? Don't complicate much. Now our concentration is only on statistics. So when they were, we can use in discrete data. So if where the mean and median cannot use, you can just go with this mode. Okay, here I have specified the advantages and disadvantages of me using mode. You can just note it down. So altogether, I have put here like what is mean, mode, and median and all. So mean means in symmetrical data, you can use where without outliers. Median means if your data is going to be skewed, like skewed means consider you are in the class and you are performing for a test. Some people are grouped to a category called who doesn't learn properly. Some people are grouped to a category called who's a good learners. Okay. So at the time, the bad learners will be going to one side, which is a negative side, that is negative skewed, and the positive people are going to one side that is called as right skewed. Okay. The skewness is of two types, which is left skewed and right skewed. We'll see the skew concept in later classes. No need to complicate much. So for categorical type of data, you can use this mode. So I have given some practice questions for you, where I have given the data set. You have to calculate mean, median, mode altogether. So now let's start with what is skewness and normal distribution. Okay, so skewness means it is an measure of asymmetry for your probability distribution. Okay, so consider you are going to have the values as consider you are going to find the probability of raining for next 1 week. Okay, so probability of raining for next 1 week. The data set will be, I have already told you the probability between, the probability value will be always between 0 to 1. Okay, so and now I'm taking the values as 0.14, 0.76, 0.2, 0 point. Okay, so all these values I'll be marking in the graph like this. I'll be marking in the graph like this. If your values are going to be in this format, like consider minus 20, like in the left side, if you're going to have the asymmetric values, asymmetric means the high value, okay? The high value and down this, like this kind of shape in your left hand side, that is called as your right skewed. Okay, so if you're going to have the values as in this format, like it is going to be in the lower side, and in the upper side if it is going, and if it is coming, like if the curve is going to be in this format, then it is called as your left skewed. Normal distribution means both will be considered. Like I told in the class, you have two kind of people now. One is for the negative class, another one is for the positive class. So where you have the normal distribution, so that is called as your normal distribution. Skewed means only failures are there in the class, that is called as right skewed. Only positive people are there in the class, that is called as your left skewed. Again, here you have to consider few things. Why we have to consider skewness is that it always affects your central tendency. Why? Because in a data set, if you're going to find a central tendency, we are not concentrating on this skewness. In mean, we took a data set, no, like 85, 86, 87 and all. If it is going to have a toggle value or the values which represent to one side, like left skewed values or right skewed values, in that time it is unable for you to use the mean median mode. So when at the time you have to go with this skewness and correct the values, then only you can go to central tendency and calculate the tendency what we want. Okay, and it impacts your statistical test and model. So if you're going to evaluate your model based upon your statistical concepts, it is not easy to evaluate. So you have to concentrate on skewness. It tells us how much how about the nature of a data set. Like nature of the data set means how the people are this is a heterogeneous class, no? You people responded, some know data science, some doesn't know data science, some belong to some other category. So here you are heterogeneous people. It is mostly like an normal distribution only. Some people are from negative side and some people are from the positive side, and there is a balance. So if there is going to be balance between all the people in a particular class, so that is called as a normal distribution. Consider here nobody knows data science, so you people are called as right skewed. If all know data science and you are much well good with the data science, that is called as your left skewed. So based upon the graph only, it is said as what is positive skew and what is negative skew. So again, the skewness is of few types. One is no skew, positive skew, and negative skew. Okay. No skew means this data is evenly distributed around the mean like this, which is a normal distribution. You can say this is a no skew also, which is like a bell-shaped curve. And you can ask me, ma'am, you are saying like this is skewness. Basically, what the representation of skewness is this curve only. Okay. In the graph, the skewness is represented with the type of graph we have. So that is called as your skewness. Positive skew means this tile will be extended to the right. Negative skew means this tile will be extended to the left. Okay, the most data will be concentrated on the left alone. So where like this kind you will have here is at that time this mean will be more and median will be more than this mode.
Okay. For example, income distribution. Few very high earners pull mean, right? So in India, we can take an example. We don't have a symmetrical kind of data set as an income distribution. Some people, some category of people, for example, nowadays it is said that AI and data science are earning more, and the people who are earning, people who are working with the developing are earning more. So these people are earning more, and we have other category of people who doesn't go to any job and they don't have a proper a home, a food, clothes. We have three kinds of people, and who earns and they have not proper salary. So at that time, you have there is no symmetrical values in this India, no. So like what I hope you can understand what I'm trying to say. Okay, if you're not understanding, let me know. I'm just trying to say like you don't have a symmetrical value in income distribution. Okay. Negative skew. Negative skew means,
Ma'am,
yeah.
one question. So in negative skew, the tail end is towards the left hand side, right? So, for example, the example you gave, age at retirement 65. So that, how come that is negative? It's like someone got retired early, might be. So why it is called negative? Like any reason for that?
See, in graph, you will be always representing the negative values will be on the left hand side and the positive values will be on the right hand side. Correct?
Yeah.
I told for the left skewed, everything will be here represented with the 65, 66. It is a kind of positive value. These values won't change, no. Age of retirement is mostly like 60 to 65. We are just sure with the value.
But on it is just basis of value, but it does not signify that data is
It
negative or.
doesn't signify, like, consider an example of government employee. Okay. It is just a toy example what I have told. Not everyone would have this same age of retirement, and we have this. We can apply this negative skew here. In my example, I have taken this value as 65. The retirement age
Yeah, yeah.
is.
But someone who retires at 65, that case is a good case than someone who retires at 40 or 45, right? So,
And one
so
thing, this skewness is not represented by good or bad thing. Okay, it is only based upon our own judgment. Okay, all these statistics things would be like it is like our own use, our own judgment, and our own need only. We will be changing everything and using. Okay, it's like in a data set, we are going to think like biasly. If I want this retirement age to be 65, I'll keep it as 65. If I want it to be like 40, I can keep it as 40. It is based upon the value, this graph is going to change, and we are representing with few wordings called as negative skew and positive skew and all. Okay, if it is going to be positive skew, doesn't mean that like this has to consist of positive values and this has to consist of negative values. The data what we are going to give is entirely based upon the bias of a person. Okay, the person will have different thought. I have a different thought of at 50 I have to retire. Some people would have thought of they have to retire by 40. Okay, this representation is only for the graph, how it looks like. Don't concentrate on value, concentrate on the type of graph. Hope you understood, Emin.
yes, ma'am.
So I have taken few examples, like example 1, example 2 and all. Here I have taken a data set and tried to mark it in the graph. So where I've taken mean, median, and mode. So based upon this calculation, I have come to a conclusion. here I told mode is greater than median greater than minimum. So I've just come to a conclusion for here the mean is much higher than median, so it is classic skew. So in graph, how we have to represent median is mean median mode is that I'll tell you. Let's take this graph. So let's take this graph. Mean means we have to take average of all these points and divide it by the central point or any other point in this graph would be a mean value. Median is like this middle value, which is 40 here, 40 or 45. And mode is the most repeated value. So if you are going to have any kind of the most repeated value here would be like these values, which is between zeros, no? So these are called as your mode. So we have to calculate all for the data point, and based upon this rule, we are coming to a conclusion whether it is a positive skewed value or negative skewed value. So all the time we cannot go mark a graph and find whether it is a positive skew or negative skew. So for that easy purpose, we are just calculating mean median mode, and based upon the formula we have, we are just coming to a conclusion whether it is a positive skew or negative skew. So in positive skew, mean would be greater than median, median would be greater than mode. Whereas a negative skew, it is an opposite side. Mode would be greater than median and median would be greater than mean. So based upon the formula, we are just coming to conclusion. This is a classic positive skew and it is a negative skew. So this I have already told you. Skewness is equal to 0 means you have a perfectly symmetrical data like this. Perfectly symmetrical means both the tail, you have tail in the left also, tail in the right also. It is said that this data is symmetrical. So just a small together I've kept it. So how we have to remember positive skew is that with this formula, and with this formula we can just have negative skew. Remember it, the tail pulls mean to the right and tail pulls mean to the left. And if it is going to be no skew, all are going to be equal. So, and again, I'm showing where this mode is being used. So these are all the things where we can see. Okay, so actually the skewness is a problem only. Okay, your data set should not have skewness. So in data processing, what it will be doing is that if the data is more skewed, we'll be trying to pre-process the data based upon our need. Then only we can use the data. So if you're going to apply for central tendency values, use median instead of mean for the central tendency. Be cautious with the standard statistical test while handling a skewed data. And consider transformation of your data. If your data is more skewed, you can consider the data can be converted to log value, and or you can just take a square root. For example, if it is going to be a negative value like -80 in your data set, at the time you can take a square root. So that square root will help us to take out the negative value now. So understand outliers before applying the central tendency when there is a skewed data. So from tomorrow, we can just start up with this. Hello.
Yeah, yes, ma'am. Able to see your screen.
Okay, so till last class we were seeing about mean median mode now. So today we shall start with skewness and normal distribution. Um, so firstly, what is skewness is that suppose consider your data is going to be like a biased data. So it did I complete skewness? Anyone?
Yes, ma'am.
I completed
Yes,
skewness. Now I have to start with normal distribution, right?
yes, ma'am.
Okay, so we shall start with the normal distribution. So last class we were saying about mean, median, mode, and skewness. So today we shall start with normal distribution. So this normal distribution is also called as Gaussian distribution. So where you can see that your data is normally distributed like this. Okay, so it won't be like negative skewed or it won't be like positive skewed, and in between you will be having a bell-shaped curve where you can say that your data is normally distributed. Okay, so you won't have any kind of skewness in your data set, and this is the most important in your probability distribution when considering your statistics. Okay, so, and you can also come to a conclusion that this continuous probability distribution that is very perfectly symmetrical around your mean. So you know what is mean, no? Average of your data sets. So that is very continuous probability distribution. Okay, so it is also called as normal because many natural phenomena follow its pattern. So there comes a name called as your normal distribution. Okay, so we can see what are the characteristics of normal distribution when seeing this bell-shaped curve. So, so firstly, you can see that this is going to be a very symmetrical in shape, like perfect mirror image around your center, and your data set is normally distributed, and it is a bell-shaped curve. And always for a normal distribution data set, your mean will be equal to your median will be equal to your mode. Okay, and the value is also going to be very continuous in nature, and it is also asymptotic. Asymptotic means it won't touch the bell-shaped curve, won't touch your horizontal axis. Okay, so that means it is called as an asymptotic. And always for a normal distributed kind of data set, your AUC will be equal to 1. Okay, I'll tell about what is this AUC, ROC and all in later classes. Okay, so if it the now for now just to take into mind, if AUC is equal to 1 for this normal probability distribution data set, always it represents your probability is going to be 100%. Okay. Okay, so then for this normal distribution data set, you have to consider few rules. Okay, the first rule is empirical rule. Empirical rule means 65 to 95 to 99.7. Okay, so which means this rule means the 68% of your data set will fall one standard deviation of your mean. 95% of data set will be your two standard deviations of your mean. 99.7% of your data set will be three standard deviations of your mean. Okay. So this is just a rule which is followed to calculate this normal distribution. So let's take one data set and elaborate what this 68%, 95 and 99.7 means. Okay. So now I'm taking an IQ score which follows normal distribution with mean value of 100 and standard deviation of 15. Okay. I'm taking both these values. Now I'm going to apply this rule, which is empirical rule. So how I have to calculate means 68% of people have IQ between 85 and 115, and 95% of people will have IQ between 70. This is just a data set what I'm taking. Okay. 99.7% of people will have IQ between 55 and 105. Okay, so some other real world examples of this normal distribution are you can consider height of the people. Some people will have this left skewed, some people will have right skewed. So you would have that normal distribution curve. And one more example is test scores and measurement errors in your scientific calculations, blood pressure for your health. So these are all examples of normal distributed data set. Some more examples are this birth weights, shoe sizes, and all. Okay. Let's take that before example what I showed here and evaluate. So now I'm having this exam scores, which is normally distributed with 70 as my mean, and standard deviation is equal to 10. Okay, so my question is about what percentage of students scored between 60 and 80. Okay, so for that I have to apply this empirical rule and then I have to calculate. So first rule is 60, no? So which is 60 is one standard deviation below. So what I have to do, I have to subtract both. 70 minus 10, this is my value. 80 is one standard deviation above mean. So above mean means I have to add both 70 plus 10. Okay. So using this rule, 68% of students scored between 60 and 80. Okay, since I'm getting the value between 60 and 80. So if I'm going to get some other value, I have to replace these two values with that value. Okay. So then I have to calculate the standard normal distribution. So where my mean is for always, you have to know that for normal distributed data, your mean is going to be 0 and standard deviation is equal to 1. Since there is no toggle between your left skewed and right skewed like kind of data set, your mean is always going to be 0 and the standard deviation is equal to 1. So for this normal distribution, you can apply this formula and calculate, which is z minus mu divided by standard deviation. Z is nothing but your original value, mu is your mean, and this sigma is your standard deviation. Okay, so I'm applying to that, and I'm going to calculate this Z score. This Z score represent your standard deviation, sorry, normal distribution of your data set. Okay, so this is how the normal distribution is calculated. And we can also do this normal distribution with some visual methods, which is histogram. We can do with the QQ plot, statistical test. These are all statistical tests which are performed, and the skewness or kurtosis. So this is what it is. So I have given one more example for this. So this is about your standard, normal distribution.
What is one standard deviation of mean, two standard deviation of mean, and three standard deviation?
Sorry, I couldn't hear you properly. Can you be a little clear?
No, ma'am. Am I audible?
Yeah, you're audible now.
What is one standard deviation of mean and two standard deviation of mean and three standard deviation of mean? So how we can calculate that and
This you're asking.
yes, yes, ma'am. What is one standard deviation and two standard and three standard?
If 68% is going to be one standard deviation, it is a rule. Okay, it doesn't have specific thing. 95% means within two standard deviation. 99% means within three standard deviations. So you will be to imagine this data set. Consider you are going to have data sets of different. Uh, Consider you're going to have a data set of a bank. Okay, so in bank you'll be considering two or three things, no, where the customers are and where this what about the salary is and how the customer account is maintained. So three different or two different data sets are taken together and grouping together. So the 68% will fall under one standard deviation, 95% will fall within two standard deviations, like that. Hope you understood. This is just a rule. I'll show you this briefly when we are going to see actual the coding things. Okay, at the time you can visualize all these things. Now just know what are the rules are. Okay.
Okay.
So for this we have to calculate the IQ and all. I didn't explain you about this IQ or and all. So after the explaining those things, you can understand this better. Okay. So we already saw about this probability, no, in the past class. So what is probability? It is a measure of how likely. So, and I also want to say what kind of questions in the interview can be asked. If they are going to concentrate on normal distribution, they can ask what is normal distribution, and what is the rules of normal distribution, and what are the characteristics of normal distribution. So where the normal distribution is used. So those are all the questions that is possible. If the interview is going to be in the theoretical way. So next is the probability basics. So we already saw about this probability basics. Just we can recap this in a quick way and move forward. Okay. So what is probability is that it is a measure of how likely an event is going to occur. And as I already told, that it's going to be always between 0 and 1. So if it is going to be 0, the probability is going to be 0. The event is always going to be impossible event. And if it is going to be a 0.5, event has equal chance of happening or not. Okay, and if it is going to be probability 1, the event is very certain and it's 100% of chance that is going to occur. Okay. The formula is, as I told, the formula is P is equal to N of A divided by N of S. N of A is nothing but the event what you want. N of S is nothing but total sample space of your event. Okay, so let's take this simple example. So where you are going to roll a die and your possible outcomes are 1, 2, 3, 4, 5, 6. Okay, so now what if I'm going to ask you what is the probability of rolling a 3 is? How many 3s are here? You have 1 3, no? So 1 divided by total number of outcomes, which is divided by 6, which is 1 divided by 6 is your answer. Okay, so the probability will be like 0.167. If it is going to be 0.1, it is like there is a chance of probability that is going to equal chance of probability that is going to occur. This which is the rolling of 3. Okay. So next is tossing a coin. So in tossing a coin, you have two outcomes, which is head or tail. So now my question is, what is the probability of getting head? So in getting head, you have two probabilities. One is head and tail. Okay, so my total outcomes are 2. So I am asking only head. So just 1 divided by 2, we'll have this one. This is about, and you have to remember 4 points in this probability. One is experiment, another one is outcome, sample space, and event. Experiment is what the event you're going to do. So now consider I'm going to ask you whether there is a chance of raining today or not. So that is your experiment. Outcome is result, yes or no. Today it is going to rain, yes. If it is not going to rain, no, that is your outcome. Sample space is total outcomes. So how many outcomes we have? It is going to rain or not going to rain. So that is your sample space. Event is the thing I want. If I'm going to ask you, yes, it is going to rain, that is that is going to be my event. Okay, so these are 3 terminologies in your probability. So I've given a number of examples here. If you want, you can just go through all these things. So where this probability is used is that you are using it in weather forecasting, medical testing, quality control, sports betting, insurance and all. You are using this probability. And there are 3 types of probability. One is classical probability. Another one is empirical probability. Another one is subjective probability. Okay, so let's see one by one what everything is. So first one is classical probability. So what is classical probability is that based on theoretical reasoning on equally likely outcomes. So before in history, we will have some theoretical outcomes. So that we are going to take and we are going to provide the probability of occurring to the event is your classical probability. In classical probability, you will have surety of event that is going to occur. Consider you're going to roll 2 dice. You know what are the outcomes, no? If the outcomes are known before, that is your classical probability. Okay, so I have given certain examples for this. And when to use this classical probability is that in the game of chance, like in lotteries, you can use that. In random selection problems, you can use. When outcomes are equally likely, you can use this kind of probability. And you are also having some kind of disadvantages while using this. Why means these are not realistic data set, no? So you know this can occur, but you know the probabilities of occurrence, but that is not surety of thing that is going to occur. That is one of the disadvantage. And you don't know the scenarios, what is going to happen next in the future. So that is all your disadvantages of using this classical probability. So next one is empirical probability. So this empirical probability is based on actual observation and experiments. It was actually happening in reality. Okay. So the all kind of reality kind of data, so you'll be using this empirical probability. I've given certain examples. Same formula only. The event divided by your outcome. Okay. So there is no change in a things. So only thing what people can ask you is that they can give you a scenario and they can ask what kind of probability it is. So you can say if it is going to be subjective, you can say subjective. If it is going to be classical, you can say classical. And if it is going to be empirical, you can say empirical. Okay.
Ma'am, can we note
Since,
it down, please?
sorry,
Can we note it down?
I'm going to share all these notes now. Can just no need to waste time. I'll share all these things. You will have from top to bottom. Everything will have. No need to waste time. And you can take random notes if you want. If you want me to stop in between, you can ask me to stop. I'll stop. Now you want time?
Yeah, I wanted to note down, but it's fine. I can continue.
Okay, okay. I'll wait. I'll wait. After noting, let me know.
Can you scroll little after?
Okay. Want to know about the classical probability?
Yeah, just. Okay, go to next. Okay. Yeah, you can scroll down.
Okay.
Okay.
So that is about all these probabilities. And in short, we will compare and Okay, so scenario, there is a whether we are going to judge there is a probability of rain tomorrow or not. Okay, so in classical, we can't use whether isn't equally likely outcomes. So we don't know about the outcomes, no, like what is going to happen tomorrow. So that is your classical probability. So we cannot use this kind of thing in classical. In empirical, so empirical means we are going to take history of data. Like last year, the same time, whether the event is happened or not, we can just take that and we can come to a conclusion whether it is going to rain or not. So it rained 30 out of 100 similar days, so which is 30 percentage. So by using this empirical, you can come to a conclusion whether there is going to be rain or not. So in subjective, there is a meteorological judgment. So I believe 70% chance based on my analysis. Okay. So if you're going to give some kind of judgment like this, so by comparing the past data as usual, so that is your subjective. Okay. I've taken one more scenario by drawing red card from the deck. So the classical is going to be in deck of cards, it is going to be 52 cards on total. No, so in that the red card is going to be 26. So just 26 divided by 52 equal to 50% of chance. In empirical, consider you're going to shuffle those cards 100 times, okay, and get 48 times, so which is 48%. Subjective, it is not applicable, we can calculate exactly. Subjective means there is no judgment in the data set, no, anything can happen, so it is not applicable in this kind of data set. So that is about so I've given one more exercise, you can just take it and work on it. Okay, today I'll share these notes, you can just refer to it. So next is odds ratio. Okay, so after comparing the probability and getting the probability, consider I'm going to ask you what is the probability of not happening to this kind of event. Okay, hope you understood what I told now. Consider I'm going to say that today the rain is going to happen. Okay, what if I ask you today no rain is going to happen? At that time, this odds ratio comes in. Okay, let's see what the odds and odds ratios are. Concepts closely related to probability, but with the important differences. Understanding what this odds ratio is very important. Okay, so basically, it is used in medical research. In medical research, compare now you're giving me an X-ray film. Okay, so that X-ray film represents that you are having a lung cancer. Okay, so now I'm going to ask you what is the ratio of not getting lung cancer means at the time you should know this odds ratio and then only you can calculate. Okay, so firstly, what are odds is that while probability tells us likelihood of event happening, the odds compare the likelihood of an event that is not happening. Okay, probability gives you the likelihood of event happening, and if it is not going to happen, that is your odds ratio. So in short, you can say what probability is that it compares favorable outcomes to total outcomes, which is n of a divided by n of s. Whereas this odds ratio, it compares favorable outcomes to your unfavorable outcomes. So always you'll be getting 1 minus p of a. Okay. So like this. The odds ratio formula is P of event divided by P of not event. So P of not event means 1 minus P of event. Okay, so let's take one example and evaluate so that you will have better understanding. So now I am tossing a coin which has probability of it's 1 divided by 2, just 0.5. So now I'm going to calculate the thing, which is my odds ratio. So applying to this formula, just P of event divided by 1 minus P of event, you'll be having this as 1 divided by 1. So let's take one more example. So where I'm going to calculate the odds ratio. So probability of rolling a dice, which is as 6 is 1 divided by 6. So I'm going to calculate the odds ratio, which is 1 divided by 1 minus the probability of event. So which is 1 is to 5. Okay. Hope you understood what is odds ratio. I've given few more examples also. Okay, if you want, you can just work on this. So we saw about odds ratio, no? So consider you want to compare the probability of one or two events together and come to a conclusion. Okay, so we are living in Chennai. So this Chennai is nearer to Chengalpet, and this Chennai is nearer to some other Kanchipuram. Okay, so now I'm going to predict whether that there is going to be rain today or not in Chennai alone. Okay, so for that I have to take two or three things together, and then only I can come to a conclusion. So I have to consider whether there is going to be rain in Chengalpet, whether there is going to be rain in Kanchipuram. So that is group 1 and group 2. Okay. So after coming to a conclusion between all the groups, I'm going to say whether there is going to be rain in Chennai or not. Okay. If there is going to be kind of examples, that is called as your odds ratio. Okay. So where I'm taking the event occurring in two different groups and coming to a conclusion. So this kind of odds ratio is heavily used in medical research and epidemiology. Okay. Okay. So after calculating the odds ratio, so if the odds ratio is going to be 1, so you can say that there is no difference between the groups. That is group 1 and group 2. If the odds ratio is going to be greater than 1, you can say that it is more likely to be under group 1. So if the odds ratio is less than 1, you can say that it's less likely to be in group 1. Let's take one example and evaluate. So I've created one 2x2 table where it consists of data set which is lung cancer and no lung cancer. So this is smokers and non-smokers. So the smokers who have lung cancer is 80. The smokers who have no lung cancer is 20. The non-smokers who have lung cancer is 10. The non-smokers who have no lung cancer is 90. Okay, so now I'm going to compare the two groups here, which is lung cancer and no lung cancer, and put it in the formula of odds ratio and come to the conclusion whether it is equal to 1, greater than 1 or less than 1. Okay, so I'm just taking this. I'm going to calculate odds for smokers. How we are going to calculate odds? So which is actual event divided by no probability of event. No, that is my formula for odds. So it's just 80 divided by 20 equal to 4 is to 1. So 4 divided by 1. So I'll be getting the odds as 4 is to 1. So next odds for non-smokers, 10 divided by 90, which is 1 is to 9, which is 0.11. And calculates odds ratio now. So odds ratio is nothing but which is the group 1 and group 2 joined together, which is group 1. This is my group 1 and this is my group 2. So I'm just combining both and dividing together. I'm getting the value as 36. Okay. So my interpretation is going to be the smokers who have 36 times higher odds of developing lung cancer compared to non-smokers. So that is my interpretation by this odds ratio calculation. Okay, let's take one more example. So where I'm having a drug treatment study. Okay, so consider the flu is there in your area. Okay, so I'm going to give drug A and drug B. If by giving drug A, the cure percentage is going to be 70. By giving drug A, the not cure percentage is going to be 30. Okay, individually, I have to calculate odds for both. So we have to calculate odds, which is 70 divided by 30, you'll be getting 2.33. 40 divided by 60, you'll be getting 0.67. Odds ratio is calculated by group 1 and group 2. Dividing together, the ratio is going to be 3.48. So my interpretation is like that. The person who takes this drug A have this 3.48 times higher odds of cure when compared to the drug B. So that is my follow-up study by this odds ratio rule. Okay, so I've given one more example. If you want, you can see. So as I told, this is used in medical research where you can this studying risk factors of diseases, evaluating treatment effectiveness. So they're using this thing. In epidemiology, we can use where this case control studies and disease outbreak investigations where they're using, and in clinical trials. So these are all things where they are used. I given more examples. If you want, you can just go through it. Okay, so there while studying this normal distribution, I told the standard deviation thing, no? I said that I'll evaluate it later. So this is what the standard deviation is. Okay, so let's take now we'll start what standard deviation is and why we need standard deviation and why we go with standard deviation and all. Firstly, we'll see what there is a problem with the mean. Okay, so in mean, imagine you have two classes with the same average score. For example, you have this class, which is this AI class. Consider you have one more AI class. Okay, so the average score of this class is also going to be 75, and average score of the other class is also going to be 75. At that time, you cannot vary between two classes, no. So there is going to be problem. So there comes your standard deviation to avoid this kind of problem. So let's see how the problem is sorted out. So now I'm just going to take this class A, which is 74, 75, 76, and the data set is going to be very consistent, like 75, 74. You don't have much variations in your data set. And in class B, you have very scattered kind of data, but when you going to calculate mean, the mean is going to be same for both this class A and class B. Okay. So in class A, the students perform similarly, but in class B, there's huge variations in performance. The mean alone doesn't tell us this. Okay, we need to measure how the spread is happened, and consider you have massive data set, a kind of big data you're going to have, and now you're going to judge how the data set is going to be, whether we can proceed with mean or standard deviation. At that time, the possibility of by using mean is not okay. Okay, so for that purpose only, to calculate how much our data set is spreaded, we are just going with standard deviation. Another one good example is consider this daily prices of one stock, which is going to be 98, 99, and there is no much spread in data. But in stock, why there is a spread in data, and we have to calculate the volatility and how much our data set is spreaded. Okay. So for that, we needed the standard deviation. So let's see what the standard deviation is. Okay. So what the standard deviation is that it is an average distance of each point from your mean. Okay. So mean is nothing but all the values added together divided by total number of values. No, consider the mean of this was going to be 100. Okay, so this 100 has to be compared with each data set, which is 100 to 98, 100 to 99, 100 to 100, 100 to 101, 100 to 102. So we have to calculate the difference of each thing with the mean. So that is your standard deviation. Hope you understood. Any doubts you have so far? So then and there you can stop me in between if you have doubts. After completing 10 days, if you say that you cannot understand or if you have any doubts in some topic, that won't work. Okay. If you have doubt, you can stop me in between and ask me. Okay. If I'm unable to clear some points, I'll say that I'll clear you later. I'll tell you later and all the things cannot be sorted out then and there, no? So if I can clear you the doubts, then and there I can clear you now itself. Anyone have doubts? Oh, all joined. But I couldn't hear any of the sound today. Why? All slept. Guys, can you join with the video from tomorrow, if possible? Any response from your side? Give thumbs up or thumbs down. Guys, you're there or you went? Others? Okay, so from tomorrow, I'll try to join with the video, okay, so that I can know what the people are thinking and if I want to clarify with the point. So usually I take classes in offline, okay. How it will be like, I'll be reading the face of the people and understand whether they understood the topic or not, whether they are just simply sitting and watching me and all, I'll know. This is online class, no? All are very silent. I couldn't know whether you are understanding every topic and how the class is going. Okay, so from tomorrow, I'll try to join with video. Okay, so we can be interactive when we can talk much. Okay, so I was talking about the standard deviation. So the standard deviation is nothing but you should be comparing your mean value with every data point what you have. Okay, so data points are nothing but the data points. This 98 is one data point, 99, 100, and not 102. Each data point you have to compare with your mean. So that is your standard deviation. If the standard deviation is going to be very low, okay, so that is said that you are very close to mean. If the standard deviation is going to be very high, you can conclude that there is a spread of your data set. So let's understand what the deviation is. So now I'm taking this test scores which has 70, 75, 80, 85, 90. I'm taking all together and dividing it by total number of values, which is said to be my mean. I'm calculating it as 80. Okay. And I have to calculate the deviation now. How the deviation is calculated? The each data set, that is data point, is taken and it is differentiated with this mean. So it is 70 minus 80, 75 minus 80, 80 minus 80, 85 minus 80, and 90 minus 80. All together you have this thing. Okay. So you will see that some deviations are positive here and some are negative here. So positive deviations mean it is above mean and it is negative deviations mean it is below mean. Okay. So now we have to consider taking the average of all the deviations. So average means you have to calculate all these added together and total data points. So now you can see that there is zero. Deviation is zero, which means there is no spread of your data set much. Okay. And you have to calculate square of your deviations. By taking square of your deviations, you can get the sum of squares like this and putting all together into standard deviation formula, which is sigma is equal to summation of x minus mu the whole square divided by n. X minus mu square is nothing but this x is your value, which is data point x1, x2, x3 and all. And mu is nothing but your mean value divided by total number of values. So for this together, you can calculate the formula. Okay, I've taken one more example and evaluated for you. If you want, you can just go through it.
Always the average standard deviation should be zero or some other value we will give.
Average standard deviation for what?
For
For this one,
example,
it is zero. For this one, it
okay,
is zero. Always the average deviations won't be zero. If consider you are going to have like this kind of data set. Where the
hmm,
values are spreaded. At that time, you don't have the value as zero. You will be having different value.
okay.
Okay. Okay, so now we were talking about this empirical thing, no, in normal distribution. So at the time we were asking what does one deviation means, what does two deviation mean? Here is your answer for that one. See, consider I'm calculating all these, comparing. Wait, I'll tell you. Okay, I've taken one example and evaluated mean, deviation, squares of deviation, sum of squares of deviation, and dividing it by n minus 1. All I proceeded, okay, and an average had been coming to a conclusion. This is the 3.16 points, like that. Okay, so now I'm going to compare two data sets. So here one data set I had, here one data set I had, here one data set I have, just one data set, two data set. If I'm going to have stock Z, that is going to be my three data set. Okay. So within one standard deviation means, it means your values are one standard deviation away from your mean. Okay, hope you understood what I'm saying. On both the sides, for this range of values, we'll be having about 68% of this data set, that is the data lies here within your one standard deviation of mean. And for within two standard deviation of mean, it means your values are up to two standard deviation, which is away from your mean on both the sides. Okay, on both the sides means we saw that bell-shaped curve, no? So that left side is one side and the right side is other side. Two standard deviation away means that is two standard deviation. If it is one standard deviation away means it is one standard deviation. Okay, so if the values are going to be three standard deviation away means it is going to be 99% of data, which is it is a type of rule where it determines one standard deviation means 68% of data is like that. And if it is going to be two standard deviation means 95% of data is like that. If it is going to be three standard deviation means 99% of data is going to be like that. Okay, overall data set, consider you're going to have 1 lakh data set. Okay, in that 1 lakh data set, you are going to compare how much your data is deviated to the mean and how it is skewed or not. For that purpose, you are using this empirical formula and coming to the conclusion. Okay, in one point, you can say what this standard deviation is, that standard deviation measures spread. How far your data points are away from your mean, that can be calculated by using the standard deviation. So now let's start with the data deviation, distribution, and variation. Okay, so in this topic, we can explore about how your data is deviated, how data is distributed, and how to explore this variance, so and all. And it is also closely related to your standard deviation. So after calculating your standard deviation, you can just calculate your variance. Okay, so this is concept helps us to understand whether this data patterns by to make the better decision for your data set, you'll need certain things. So all these three topics will help us to explore that. Okay. So firstly, we'll start with data deviation. So this data deviation is of few types. One is the mean absolute deviation, which is also called as MAD. Okay. Average of absolute deviations without squaring. So how we'll calculate standard deviation, we'll be squaring everything and then we'll be calculating, no? But in mean, we won't be squaring anything. Directly we'll do, which is summation of x minus mean divided by n. So let's take this example. So this pipe symbol will help us to calculate the absolute value. You know what is absolute value? Absolute value will help us to take out the negative signs. Okay. So in that standard deviation, we calculated the average mean, no? So in average mean, we know we'll also get negative outputs. There is a chance of getting a negative outputs. Whereas in this mean absolute deviation, that negative sign won't be there. So for that, we'll be just taking this absolute thing, which is 70 minus 80, 75 minus 80, 80 minus 80, 85 minus 80, 90 minus 80. All together, we'll be taking the absolute value, and these are all my absolute values, and taking the summation of all divided by total number of values, which is divided by 5. 30 divided by 5 is equal to 6. So on an average, the scores deviate by 6 points away from mean. Okay, so next one is standard deviation. So we learned this now. Yesterday means we saw before, no? Just yesterday. Uses square deviations. Why square deviations means which negatives eliminates negative value. In
I have a
standard
doubt
deviation,
here. Sorry to
yeah,
interrupt.
yeah.
Yeah, in the first one, the mean absolute deviation, we are calculating that 70 minus 80 is absolutely minus 10, right? But why we are taking as a positive
That
value
is
here?
the usage of absolute value. This symbol, no, this pipe symbol
Oh, okay,
that
the
is called
pipe
as an
symbol taking.
absolute
So,
will be
okay,
helping us to take out the negative symbol. That negative won't be there. That is the usage of this mean absolute value. But sometimes you cannot use this mean absolute value. Why? Because there would be essential of some data sets where this negative signs will be needed. Okay, so when you need accuracy in your thing, you cannot use this mean absolute deviation. At the time, you should go with this standard deviation only. Okay,
okay,
I'll tell
okay.
you where you can use this and all. We are going to come next. Why square deviation? So in standard deviation, we did square deviations. No, we squared and we calculated. Why? Because it eliminates negative values again and gives more weight to extreme values. Extreme value means, see, one data set is 23, another is 24, another is 25, and some data set 100. Okay, so this is my extreme value in this data set of 23, 24, 25, and 100. So at that time, more weightage will be given to this 100 alone. So there you can use this standard deviation, and mathematical property is useful for this statistic thing. So we are going with the square deviations, and it connects to your variance. So though these are all the things where
I'm one doubt. So standard deviation gives more weightage to extreme value. It's like the outliers.
yeah, that is it out. I'm going to come next. It is the next point. I'll tell you. So when comparing to this MAD versus this SD, this MAD is simpler. Why? Because we are firstly eliminating every negative signs and coming to the conclusion. No? So that is very simpler, and it treats all deviations equally. So deviations equally means one point is going to be 23, another point is 24, another point is 45, another point is 100 means. So it gives variations between this 24 and 25 also, whereas this 45 and 100 also. So all the deviations are taken into mind and the answer is given while using this MAD thing. Whereas in ASD, it is more commonly used, but it is always sensitive to your outliers. Outliers means we took this data set now where 23, 24, 25 and 100. So 100 is your outlier. Outlier means that cannot be joined with a linear line or any curve. That point would be in an outlier in your data set. So at that time, it is sensitive when you use the standard deviation. Okay, so if you want all the outliers also to be taken into mind, you can use this MAD. If you don't want the outliers to be taken into mind, you can use this SD. Now you understood?
Uh, so basically the formula is same. It's just the in MAD you are using the absolute value,
Yes,
right?
yes, 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 yes. The formula is same. Only thing here you are removing the negative points, whereas in AST the negative things are taken into mind, but at the last only you are squaring. See here, the last only will be squaring. Here and all the negative signs are not taken out. Here only you are squaring. This will help us to take for better calculation when you are having more outliers. When outliers cannot, you don't want much outliers in your output. How to say this? When you don't want this outliers to be calculated, or when you are not in need of it, at the time you can use the standard deviation.
Okay.
That this is 1 standard deviation, 2 standard deviation, and 3 standard deviation. In 1 standard deviation, 68%, 2 standard deviation 98, 3 standard 99. Let's take this data set and evaluate for its 68, 98, and 95. And this is about the calculation. And I have this practice exercise. If you want, you can just go through and evaluate what this is. So, and in normal distribution, we calculated that score, no? So I've given it one more thing. So this and all we saw already. So this is my bell-shaped curve. So for better understanding, now you can understand this better way. So this is my bell-shaped curve for my normal distribution. So if the data set is going to be between like this bell alone, which is my state percentage of data. So where this not touching the horizontal line, but it is like very slantly, it is going to touch the horizontal line. So at that time, it is like both the sides together, which is 95.44%. Here it is not touching the horizontal line, but it is going to touch. Never ever this in normal distributed data set, your the curve won't touch the horizontal line at all. Okay. So that's why we are applying this rule. So this is about skewness. We saw about skewness, not just right skewed, left skewed, and all. I've just recapped everything. Okay, and one more thing I want to say, there is 2 other distributions called as uniform distribution, and it's not in your syllabus, but I want to let you know other distributions also. So this is uniform distribution. Another one is bimodal distribution. So bimodal distribution means if you are going to have 2 data set like this, one data set is of these type, another data set is of other types, and there is going to be 2 peaks of group A and group B. Consider this is a stock market of day 1 and this is a stock market value of day 2. At some time like around 1 p.m. the stock value is hiked up like this. And here also around 1 p.m. the stock value is hiked up like this. Okay, so if you're going to compare with the 2 kind of normal distributed values of like this, that is called as bimodal distribution. Okay. Another one is uniform distribution. Uniform distribution means, let's take an example of rolling a Faraday, where consider you are going to play with 6 people. Okay, so every time each people will roll a die and they get a value. Okay, like one people will be getting 6, one people will be getting 4, 5. Mostly all will be getting this all values. No, when the trial of 100 times you're going to roll a die means there is a probability of getting, everyone will get a chance of rolling 4, 5, 6 and all. So at that time there is going to be a uniformly distributed kind of data set where there is won't much variations. So that is one of the example of this uniform distribution. Lottery numbers. Those are all examples of uniform distribution. Okay, let's see few wordings. Like wordings means representation of all these data set and all. Firstly, we'll see about shape. Shape means we'll see whether that is symmetrical or skewed. Skewed means the data set would be on one side alone, which I already showed you. Symmetrical means that normally kind of distributed data that is called symmetrically. Unimodal means only one curve. Bimodal means two. Multimodal means more. Like this, we are going to have many group A, group 2, group 3.